Okay, so who has a ham radio license? So we've got quite a few hams here. Okay, so there's no big surprises in this talk for you, but I hope you'll find something interesting in it. Who is studying for a ham radio license at the moment? Okay, and who's thought about starting to apply for a ham radio license? Who would like to? Okay, very good. So ham radio is a scientific hobby. It's non-commercial. A license is required to transmit, and anybody can receive without a license. Ham radio has a lot of things in common with free software development. Learning and education, experimentation, innovation, volunteering, and by the way, FOSDEM are still looking for volunteers if anybody is interested. Technical excellence, science, and communications, of course. Ham radio plays a big role in emergency communications. In many parts of the world, when something goes wrong, radio amateurs are the first on the scene. Hardware skills are optional. You don't need to know everything about electronics or constructing circuit boards or antennas to be successful in ham radio. Many people are interested in digital modes and things like software-defined radio, which is the purpose of this room today. You do need to know about the theory in order to pass the exam. Most hams only have a subset of skills. Some people are very, very strong with digital modes or software. Others have very good skills and workshops for building antennas. So people often come together through clubs and through their local community to put these skills together and build complete solutions. There are also national associations which join together many of the clubs. It's not a free-for-all. I mean, in the free software world, we often talk about the freedoms that you have with software. In amateur radio, there's no religion, no politics, and no entertainment. Otherwise, you can use it for social communications. So to speak to your friends and family, if they have licenses, you can use it for experimentation, but you can't use it for other types of broadcasting. So it's not as free as the freedom in free software. This is an overview of the radio spectrum. One of these little dongles, which I'm going to demonstrate shortly, will pick up everything from about 24 megahertz, somewhere about here, all the way up to maybe 1.7 gigahertz. With an up converter, which you can add to the dongle, like this, you can start getting signals from down here as well. So propagation is a big topic in amateur radio. At those lower ends of the spectrum, the longer wavelengths, you can make contacts all around the world with signals that are reflected through the atmosphere at various times of the day or night. On the higher frequency, so VHF and UHF, you can make local contacts, often with a higher quality using an FM mode, but you won't get the same distance. You won't get signals reflecting through the atmosphere and going all the way to Australia. On the other hand, you can bounce those signals off the moon and they'll come back if you have enough power. There are many different modes. It's okay. There are many different modes. CW or Morse code is the most basic. You've got single sideband, frequency modulation, packet data, which is a digital mode, and television. And you can do all of these types of transmission with amateur radio. Yeah, the dongle here only costs about $20. The quality of the signals you receive will depend to a large extent on the antenna that you use. With a little antenna like this, which will cost you about $5, you can do a very good job of picking up a lot of signals in your local area, so for a few hundred meters around where you live. If you create a more elaborate antenna like this, this is a 20-meter loop antenna that I've constructed myself using bits I purchased off the internet. And if you use the right cables and connectors, and you attach this to the up converter and then into the dongle, you can receive signals from all around the world. So I'll just pull this out so we can pass it around the room. The way this was constructed, I purchased a 25-meter roll of enamel copper wire, which costs less than €10. I purchased a box of these little insulators off eBay. Once again, you can get boxes of them for less than €10. This is a balun. It connects from the enamel copper wire to the coaxial cable, like this. And that costs, the costs of those vary. This one is rated to transmit up to 300 watts. Something that can transmit more power might cost more money. There are also some cheaper ones that are not suitable for transmitting. But that one was about €30. I get the measurements off a website and just cut the wire to the right length and strip off these little bits on the end of the wire, put them into the terminal blocks on the balun. So it's tied on here for strength and support, and then it's connected into the little terminal here for electrical contact. Now, would anyone like to help me pass this around the room? Just try and unroll it somehow. It might be, yeah.
Is it like a dipole or an end fit?
It's a loop, yeah. So we'll just hold that together, and then if you sit and just take it around the room, yeah. You can keep that end here, yeah. We'll just show how big it is. So if you maybe.
Oh, you want to roll it?
Yeah, just try and unroll it. I spend a few minutes on this just to emphasize that a lot of effort goes into making the antennas, because this is a big part of success in amateur radio. With a large antenna like this, even with a couple of small bits and pieces like this that I've purchased off the internet, I really can receive signals from all around the world. But I wouldn't normally operate the antenna in the room. I'd have it outside somewhere, or possibly in a rooftop or on a balcony. The transmission line that you use also makes a big difference to the success of your radio system. This is a very thin 50 ohm coax. Most amateur radio systems use 50 ohm, so not the 75 ohm coax you'd use for TV. But this one's quite thin. We'd use a larger, thicker coax for this type of HF reception, especially if we had to run the cable 20 or 30 meters. You can see some of that outside where the local amateur radio club have set up a booth, and they've got a mast outside the building. Did anyone see the mast when they were coming over here? Yeah, okay. These little connectors, they also make a big difference to your success. So if you buy really cheap ones off eBay, I'd suggest you test them thoroughly because they may be holding you back if they're not working.
How would you know?
How would you know? You'd need some test equipment, or if you actually have positive results, then you might have a good sign that it's working. If you're transmitting and you use something like the SWR meter, that might also give you clues that your connectors are not working well, but you don't know if it's the connector or the cable or the antenna. So this is a block diagram of a radio system, so a real radio, not a SDR. So the number of oscillators, mixers, finally a FM demodulator, and eventually we get an audio signal. So that's just for receiving. A transmitter block diagram looks similar but in reverse. SDR is a lot simpler. You've got a filter, some amplification, an oscillator and a mixer, and then an analog digital converter. And everything else from that other block diagram is then done here in the software. So these are the RTL SDR dongles. Who has one of these already? Okay, everyone in the room. Who doesn't have one? Anybody? Yeah, so they're very easy to get. If you're purchasing one of these, you'll find the most generic ones for TV reception are less than €10. But they don't have the stability to get narrowband signals from transmitters like this. So that's why we buy these slightly more expensive ones, which are about €20, which are made for the purpose of SDR, not just for TV reception. They basically have a different crystal oscillator in them with more stability. They have a better case. And they have the SMA connector, which allows you to connect to most of the antennas and other things you'll be interested in. So a little bit about Debian. Is one of the things that brings me here today is Debian. In Debian, we have a whole operating system. We have over 20,000 packages. Everything is free software, so we guarantee that we give you the source code for everything in Debian. We have a big process for producing Debian and for ensuring the quality of a stable release of the Debian operating system. Within the Debian community, like in every community that you'll encounter, in the free software, you'll find a few radio amateurs. We've got about 1,000 Debian developers, so we've got quite a few radio amateurs in there. And we've grouped together to produce packages of stuff that's interesting for other radio amateurs. That's the Debian Hams team in Debian. And what we have is a blend of Debian, which means you can actually build a Debian CD that comes pre-installed with all the stuff you'll be interested in, ready to run in the shack. You can run it from a CD or DVD, you can put it onto a USB stick, put it into an old computer in the shack, and get up and running right away. Now, who uses Debian already? Yeah. And who uses a derivative of Debian like Ubuntu? Okay, so it's well known that Debian freezes every 2 years, and then everything sits there at the same version for 2 years. And in a fast-moving area like SDR, you may not be satisfied with that. You may want cutting edge releases of things. We have a way of doing this in Debian called the backports system. So we actually build backports of the cutting edge releases of things on a stable system, and then we release that into the backports catalog so you can very conveniently install those packages with the same apt-get utility that you use to install any of the stable packages. So you can see an example here from GQRX, which is an SDR application. The stable release of Debian has version 2.3.1. The latest version is 2.6, and the backport, which is a BPO here, is also 2.6. So somebody who installed the last stable release in 2014 can get this immediately without any compiling. So this makes the backports very relevant for fast-moving fields like SDR. So going on to the demo. How are we going with the antenna? Where did the antenna end up?
Currently here.
Down here. Okay. Any questions about the antenna? Okay.
One question regarding the power and the signal itself.
So, do we have a microphone for questions?
I'm afraid no, you have to repeat them.
Okay.
Okay. It's the power and the signal. You usually need to mix them. So this device, especially when you are transmitting for high power, the signal is already very low power. So how you mix this with this small antenna, or the device do it itself?
This antenna. So he's asked me about transmitting, with high power. This antenna would not be used for a high power transmission. This other antenna can handle high power RF. It has the insulators so that you don't handle it with your fingers or attach it to your furniture or something that you might damage. And if you put it up high, then you're unlikely to kill your cat. So, thank you. But yeah, you actually have to check the thickness of the wire that you use for building an antenna like this. Like this one, you can see it's actually not that flexible. It's not a really thin wire. Like if you opened up a wire from your speakers and pulled the bits of copper apart, they're a lot thinner than this. This is actually quite thick and can handle a few 100 watts of power.
This point, but when it comes to the signal itself, signal already on the software defined to you, and the power should be external. So does this happen or mix it with this device?
I'll come back to you after the demo. Yep. Okay.
Sure.
Unfortunately, we have some signal sources nearby. So this is GQRX. And this is available as a package in Debian, maintained by the Debian Hams group. You can just install it with apt-get or synaptic, and it's ready to run. The first time you run it, it will ask you about your devices, and you just tell it to use this one if it's connected. This value has to be changed when using the up converter. For this up converter, the crystal frequency is 125 megahertz, so I have to put that value in that local oscillator box there. And I'm not using the up converter today, so we leave it at 0. 430, 433 megahertz. We've selected narrow FM. And then we're ready to go. Now, thanks to the squelch, we don't hear anything just yet. I'll put my radio back on. So there's the signal. Did everyone see that just then? I'll try and communicate with someone. CQ FOSDEM, BK3 TQR, and radio demo. Okay, so we received the signal through the computer. All I had to do was to click to put the tuner onto that frequency, so we can actually see the whole band. Hello? Yeah, we're receiving the SDR definitely. Unit QSY 443.8. We can see the signal has now moved up the spectrum. We're not receiving it on the SDR because we have to tune it again. Let's try 10 meters now. I'll change down there on the SDR. Now I don't have a transmitter for 10 meters. So there's a big one out there on the table. So there's every chance we might receive something. There's also that big antenna, which you've all seen out the front. Now on this band, we're more likely to be using a sideband instead of a head. I think we saw something in the 10-meter band, but we couldn't quite hear it. more difficult. There's obviously a much lower bandwidth for the signals on that band. On the FM band, we're looking at maybe a 10 kilohertz, 12 kilohertz wide signal. Here we're looking at a signal that's maybe 4 kilohertz wide. So that's where it's really important to have a good quality dongle. Yeah, so thanks everybody for coming today, and feel free to come and join us on